Hello, good afternoon, everyone. I am Singh Dhania, lecturer, Department of Mechanical Engineering, IIMT College of Polytechnic, Greater Noida. Today, we will learn about the basics of CAD, CAM, CIM. So, let's begin. In the introduction, in the today competition, industries have cannot survive unless they introduce the product or existing one with quality. Cost must be lower, shorter lead time. So to achieve these goals, we have to move towards the computer oriented manufacturing. In the CAD, computer aided design, it means the design with the help of the computer, in which we do the creation, modification, analysis, and optimization of designs. So through the use of computer, we use we do the design of any component in the computer aided machining. The machining or manufacturing done with the help of computer is called computer aided manufacturing. So designing, manufacturing, analysis with the help of computer, if we do, then the product quality and cost, accuracy, precision, all will increase. So CAD CAM SIM technology are set of advanced computer based tool. It is a tool and technology that are used to design, manufacture and manage products efficiently. We know CAD stand for computer aided design, CAM stand for computer aided manufacturing, and SIM, which is integrated to of CAD and CAM called CIM, and it stands for the computer integrated manufacturing. These three technologies are interconnected and have become an integral part of modern manufacturing processes. So these all processes are needed to to manufacture the product by the use of computers. So what is the engineering design? Product design manufacturing engineering involves, and the design involves the study of design methodologies, engineering materials, and the selection and control of manufacturing processes used in development, design, and manufacturing of engineering products. Emphasis is on quantitative and systematic analytical technique and methodology are used to solve real-life industrial design manufacturing controls. So in the design section, engineering design, we use the design methodologies, engineering materials, and the selection and control of manufacturing processes and development of a product. As we see this flow chart, which shows the engineering design, the steps, what we follows. In the very first, we define the problem. Whatever the problem we have, we first defined it. After that, after defining the problem, we do the background research about the problem, what kind of problem it is, and what are the factors which are affecting this problem. So, second is do background research. Then after specify requirements. When we do research, we find the what is needed to fix this problem. So according to the research, we specify the requirement. Then after requirement is specified, the brainstorm, evaluate and choose solutions. It means we all do the evaluations of the problems. In the next, develop and prototype solution, and then after the test solution. What happens if test solutions meets the requirement, then we communicate the results. If test solutions doesn't meet the requirement, then we do further the brainstorm, evaluate and choose solutions. We go back to this step, then we develop and prototype solution, the test solution, until it comes the solution which meets the requirements. We do that. This section is all the repeated mode until we get the solution which meets the requirements. So this is the flow charts where the beginning of an engineer design has begun. Computer integrated manufacturing. Manufacturing is supported by the use of computer. It calls the computer integrated manufacturing. It is the total integration of computer aided design. In this computer integrated manufacturing, computer aided design and manufacturing, also the business operations and database are collected to the single platform. It integrates all the components to a single platform, either it is design, either it's a business operations, either it's a database and whatever it is. So CIM has a wider space to work. The same concept is that all the operation related to the production function is an integrated computer system to assist, enhance, and automate the operations. So basically, the computer integrated means to bring all the uh, methodology, all the designing, manufacturing, business operations, databases, and the other activities through the computer in a single platform to do the manufacturing. It is all the computer integrated manufacturing. What the scope of CAD, CAM, and CIM? We see in the middle of this chart is factory operations. What are the factory operations? For the factory do the design, factory do the manufacturing planning, manufacturing control, and business functions. So this all be done by the factory operations. The latter circle we have seen is the scope of CAD CAM. This all the circle in the factory operations comes under the scope of CAD and CAM. CAD and CAM means these all activity is controlled by the CAD and CAM system, where manufacturing planning is done by the computer aided manufacturing, design is done by the computer aided design, manufacturing control is done by the CAM software, and business functions also comes under the computer aided manufacturing. When we all together combines, it comes under the CIM. CIM integrate actually in the scope of CAD and CAM. Business function doesn't come. Business functions comes under the computer integrated machining. So these all three comes under the CAD CAM and business function including all these two circles comes under the SIM. So SIM has the wider space to work. Impl- Implementation of typical CAD process on a CAD CAM system. Implementation, how we implement the CAD process. So very first, delineation of geometrical model. We first have to draw the geometrical model, definition, translator, geometrical model, design and analysis algorithm. Now we do the design and analysis of algorithm, drafting and detailing, documentation to CAM process, interface algorithm, and design chase. So these are the steps in the CAD process implementations, how we do implement. So very first we start with the geometrical models, design analysis, drafting, detailing, documentation to CAM process, interface algorithm and design change. So what is computer aided design? Two type of activities we do. Very first is synthesis and analysis. Synthesis and analysis. In the synthesis we have to make something, but the analysis we do the analysis whether the things we have done it is okay or not. So synthesis, two type of activities, synthesis and analysis. Synthesis is largely qualitative and hard to capture on computer. Synthesis is very hard to capture on the computer. Synthesis can't be do at on a large scale, but the analysis is majorly done on the computer. Design, evaluation, rapid prototyping, software package for design optimization is largely done on. So analysis is being done on the uh, computers. CAD CAM SIM, we see this chart where process of CAD CAM SIM. Here we do the flowcharts in the very first CAD. The process, this process start with the design. Very first, whatever the problem it is, we first do the design of that particular problem, particular parts. So design data, geometrical file, uh, इसमें in this wireframe modeling or surface modeling we do. These are the uh, surface modeling, wireframe modeling are the commands used in the CAD. After the design is completed, this data is transferred to the CAM. What the CAM does, tooling selection, machining conditions. All the manufacturing activities is done by the CAM software. Here we see this figure. This figure shows the surface modeling, wireframe modeling is like that. This is this design is goes to the CAM software. The CAM software turns seem like that. The tool is move around this wireframe that is shown in this figure uh, in the blue color. So generating tool path file, matlab how to tool move on the trajectory of the workpiece. So this is done in the CAM. After that, the CAM process completed. The verification is started. Verification means tool path error detection. While machining, there is a tool path error might have come, so it must be detected, tool collisions and geometry verifications. Then after the post processing means downloading NC program. This all NC program we have to download. The CAM software, all these things done. Then we post processing means download NC programming and move to the CNC machine where the part is manufactured. CNC machining, then it is the finished product we get. If we need the program to be changed, then again program correction, it goes to the CAM software. Again, this is the repeated thing. So if we do any changes uh, in this, uh, in the program that we made. So this is all the integrated all the things CAD, CAM, and CIM. So component of CAD, CAM, and computer aided engineering. See, it is also the computer aided engineering, computer aided manufacturing. So what is the component? We have the component, two type of component. One is hardware, one is software. Because we use the computer. So hardware includes graphic device, their peripherals for input and output operations. And for the software include packages that manipulate, analyze softwares we know. So for the designing purpose, we have the AutoCAD, CATIA. For the analysis, we have the ANSYS. So software is required. Software components, CAD, CAD software allow designer. CAD means AutoCAD or AutoCAD, SolidWorks, like that. Software is required. CAM software plans, manage, control, and if CAM is done, it is through the software. Computer aided engineering, analyze, design, geometry. This is also done by the computers. We see this chart. We need the application database. This database transfer data to application program. It interchange data with the graphics packages. It also connected with the graphical terminal user input IP devices. So these are the connected to each other, transfer data to each other to complete out these all the uh, activities. Hardware components, hardware configuration of CAD system. We need the display devices like raster, scan device, plasma panel, liquid crystal display, type of images like halftone, grayscale, colors, memory requirement. We need to store the data, raster scan, graphical terminals, concept of pointing and positioning. So these are the hardwares we need to of the use of CAD and CAM. Design workstation. Design workstation means where the design has to be done. So for this, we need the CAD system. We need any software. Well, first, we need the hardware, means we need the computers. We need the CAD software, graphic terminals, operator input devices, one or more plotters to plot the central processing unit. Storage, we need to store the design. So we see this graph. CPU is connected with secondary storage and CPU also connected to the plotter. CPU connected to the graphic terminal, which is connected to the workstation. So this space is the workstation, which is connected to the computer. The computer can be storage and output devices. The application of computer for design. Here, for the designing purpose, how the idea has. emerged. First of all, see this flow chart, recognition of needs. What the need we have. So first we recognize the need. We must have the need. Second, we define that problem. After we define this problem, we do the synthesis, then analysis and optimization, then evaluation, then finally we do the presentation. If evaluation results are not proper, not good, then again we return to the step of synthesis. At this step, analysis and optimization result are not okay, then we again go to back to the synthesis, and the process then started synthesis, analysis, evaluation, and presentations. In the synthesis, geometrical modeling is done, analysis, engineering analysis being done, evaluation, designing, review, and evaluation, automated drafting. So these are the things which have been done for the design. CAD tool required to support the design process. Design phase required CAD tool. So these are the requirements we have discussed in the previous slide as well. Design optimization. We have to optimize the designs where the design have to be optimized, must be clear. There is no extra data in the design. So design is optimized, customized application, structural optimization, design evaluations, dimensioning, tolerance, drafting and detailing, design review and evaluation. So we all do the things in the CAD software. Geometric modeling. In the geometrical modeling, we we create the model. It is concerned with the computer compatible mathematical description of the geometry of the object. To use geometrical modeling, the designer constructs the graphical image of the object on CRT screen of the IGS system by putting three type of command. To geometrical modeling, we have to create the model of any parts or of any uh, manufacturing products. Engineering analysis. So engineering analysis, the analysis may involve strain calculations, heat transfer, computational or use of dynamic behavior of the system being designed. So we analyze the strain, heat transfer, and computations. So for this purpose, the computer can be used in aid in this analysis. So these are all being done by with the help of computer. Two important example of this type of analysis of mass properties. We analyze the mass. Second is the finite element method. Two methods we use: mass properties and finite element method. Analysis of mass properties by in the mass properties we use the surface area, weight, volume, center of gravity, and moment of inertia. For the plane surface, the corresponding computational may include the parameters, might have area, inertia properties. In the finite element method analysis, with this technique, the object is divided into the largely number of finite elements, which form an interconnecting network by contracting nodes. We what we do, the design is divided into the uh, large number of parts, and at the node, all the mathematical calculation done by using a computer with significant computer capability. The entire object can be analyzed, stress, heat transfer, and other characteristics. So implementation of typical CAM process on a CAD CAM system. Implementation implementation of CAM process. We do the start very first start with the geometrical model. Then we need to the interface algorithm. Then after process planning, inspection, assembly, packaging, then to shipping and marketing and NC programming. So these are the steps which use the which used in the CAM processes. With the manufacturing database from CAD CAM. In the conventional manufacturing cycle practice for so many years in the industry. In conventional, we do not use the computer. We do the manually the things. Manually we run the machine. Engineering design were prepared by the design draftman. There is no use of computer and then used by the manufacturing engineer to prepare the process. These are done in the conventional manufacturing. The activities involved in the designing the product were separated from the activities associated with the planning. But in the integrated CAD CAM system, direct link is established between product design and manufacturing. We left the conventional method of designing and manufacturing. We use the computers to design and manufacture the products. It is a goal of CAD CAM not only to automate certain design phase of design and certain phase of manufacturing, but also to automate the transition from design to manufacturing. Means it is not only automate the system, but it transition from the design to manufacturing. It is all being done in the CAD and CAM softwares. This graph shows the database which is transferred from CAD to CAM. Here we see that this is the interactive graphics. CAD in the CAD geometrical modeling we do, engineering analysis we do, design review and evaluation, and automated drafting technique. Automated drafting. This database is interconnected with the CAM software. In the CAM is manufacturing. We use the tool and picture, ANSI programming, CAPP, PPC, and scheduling. So these are the scheduling of jobs, scheduling of tools, ANSI programming, tool fixtures. After that, the production will start and we got the product. So these CAD and CAM are interconnected with the CAM process and the data is transferred to each other. So computer technology in automation. Automation means negligible human interfere in the manufacturing. So most of the automated production system implemented today make use of computers. So if we use largely CAD and CAM, it become the automation, automatic manufacturing. In the addition to its particular emphasis on the use of computer technology, it is also distinguished by the fact that the include not only the manufacturing operations but also the design and planning. So what benefits of CAD? So by using the CAD software, productivity increase. We we need short time. Definitely, computer save the time. Reduce engineering personal requirements. Uh, Modification are easily because through the command we do in a very short time we do the module. Response. Computer is a faster thing, so we do the response which is faster. Design also improved accuracy. No doubt, there is accuracy is around almost 100% we got. Avoidance and subtraction to meet the schedule. So benefits are more by using the CAD. Also provide better functional analysis, avoidance of subcontracting, meet schedule, assistant preparation. minimize cost, transportations, and all are the benefits of the CAD. Product cycles, where the product cycle means from the very first phase, the design phase, and through the end customer, how the product is reaching, it is called the product cycle. So we see here the two charts. In the very first chart, product cycle and design and manufacturing, and second chart, product cycle revised with CAD CAM and overlay. In the very first chart, we do not use the CAD CAM. So this cycle is start from the product concept. Here the product concept starts. We do the design. We do the design. Then we do the drafting. When do the process planning. We do the production scheduling. What happened? A process planning, order new equipment and tooling. See, it depends the tooling and equipment depend on the type of products. So if we planning the process and what the extra tooling needed, we must order it. So ordering is needed at this step. Further production scheduling, after the production start, then when product are made, we know the quality, we know the customer markets. So this is all where the product has emerged, started and reached to the final. So this cycle is called as the product cycle. This is also the chart of the product cycle, but with the help of CAD and CAM overlay. In this cycle, we use the computers at every step. Here, whatever product concept, we use the computer here also. Designing is done by the computer. Drafting is done by the computer, automated drafting and automation. Process planning is done by the computer-aided process planning. Production scheduling is done by the computerized scheduling. Material requirement planning, so flow control. Production is done quality control, computer-aided quality control. So at every step of the product cycle, computer have been added. So this is the product cycle revised with the use of CAD and CAM. So here we get the product, good quality product in a shorter time, good quality accuracy will be higher. So, so, this is all about the introduction of CAD, CAM, and CIM. I hope it will. I hope it will be helpful to you. Thank you very much.